Drones are actually not as hard to automate as driverless cars. Why? Well, first of all, when you're in an aircraft or when an aircraft is in the sky, there are not 50 other people of questionable intelligence driving closely, flying closely to you on their cell phones at all times. That being said, the FAAs have a problem with pilots and texting while taxiing, right? So driving is not the only place where your cell phones are causing distraction. So again, because the obstacle density field is not nearly as high, the sensors are far more mature. Planes have been flying by themselves for over 30 years. Right now, in every plane that you fly, every commercial aircraft you fly, the pilot only touches the stick 3 to 7 minutes of the entire flight. They only touch the stick on takeoff. The reason is because the airlines want to save gas. When planes fly themselves, they save a tremendous amount of gas. They reduce the carbon footprint by a measurable amount. And when the planes land themselves, they save the tires. Humans landing on tires, we kind of get on the brakes too hard, too uneven. But when the automation does it, the tires last much longer. And that is why the commercial aviation companies do not want pilots flying these aircraft. They want them as little as possible on the stick. Then that leaves cars, where we need knowledge and expert-based reasoning. And why is it so much harder to do that? It is because for all the possible events, high levels of uncertainty, it's not clear that computers, well, it's not, they cannot right now reason inductively. So most of you, when you were learning how to drive a car, you were told the example, the ball rolls in the street in front of the car. What do? Well, you look for kids, you have this mental imagination, there's one or more kids playing with the ball nearby, and you get your sensors up looking for the other events because you've made a guess about what is causing that ball in the street. Driverless cars, self-driving cars right now simply cannot do that because we do not know how to do inductive reasoning in computer science, and it's not clear that that's in the immediate future. Humans versus computers. So this is actually called the Yerkes-Dodson workload curve. And it tells us that there's some moderate level of workload that you perform best at. If you're working too hard, you'll lose attention, you'll drop your workload. It's just difficult to stay engaged. Consequently, if you're bored, and we see this quite a bit in aviation for pilots because it is actually really boring to fly a plane that's flying itself most of the time, you will also lose attention and you'll be easily distracted. Because it's still difficult for computers to take all the abstract pieces. They're very data-driven, and to extrapolate to the whole. That's deductive reasoning. We look at the whole, and then maybe if we need to, we abstract down to the individual data points. So we're still pretty far from having cars and systems understand